welcome back. This is number 12 in my Fog of War series. This one just has some mixed rules. One new rule, which I'll go through in a minute, but it's a very simple one. So I hope you like this one. It's a little bit tricky, but it's still only a moderate level puzzle. It's not too hard. So I'll go through the rules now, and you can have a go at it yourself. There's a link in the description below if you would like to try it. So normal Sudoku rules apply. Cells separated by a black dot are in the ratio 1 to 2. So this black dot here has to be in the ratio 1 to 2. Or in the ratio written in the dot. This one over here has a 4 in it. So that one's in the ratio of 4 to 1. Which means that one of them has to be 4 times the other one. Cells in cages add to the number in the top corner of the cage. So these dotted lines here are cages. So there'll be a little number up in this one, for example, depending on where that goes. Those cells have to add up to that number in the top corner there. Adjacent cells on green German whisper lines must differ by at least 5. So if we have a green line along here, if that's a 1, for example, the next one would have to be at least 5 more. So it could be a 6, a 7, an 8, or a 9. And these tend to go like 1, 7, 2, 8, up, down, up, down, up, down along the line, either side of 5. Because you can't have a 5 on a German whisper line, because 5 and 5 is 10, and 5 take away 5 is 0. So you never have a 5 on a green German whisper line. That's a little clue there. Cells on the blue thermometers must increase in value going away from the bulb. So these just get bigger as they go up and away from the bulb. Cells on pink Renban lines are a group of consecutive numbers in any order on the line. So consecutive just means one after the other. So you could have 5, 6, 7, but in any order. Or you could even have a long one like that, but they can all go in any order. It would have to be 2, 3, 4, 5, 6, 7, 8. So they all have to be consecutive, but in any order along that line. Every value in a 4-value circle has to be assigned to one of the surrounding cells. So here's an example here. Those numbers have to be in these cells somewhere, but not necessarily where they're marked in the circle. And next one, numbers along an arrow line, sum to the circle at the end of the line. That's fairly simple. If you see a circle with a line coming out of it with an arrow on the end, then those the numbers on that line have to add up to the number in the circle at the end of the line. Now this is the new one. Numbers on grey palindrome lines must read the same forwards and backwards. That is, from either end of the line. So there's the start of a grey one here. Let's say it goes along to there. You have to be able to read the numbers the same that way as going back the other way. So it could be 1, 2, 4, then it would have to be 2, 1. So they're symmetrical, in other words. So then you go 1, 2, 4, 2, 1. It reads the same backwards and forwards. Next one, numbers outside the grid are sandwich sums, which show the sum of the numbers between the 1 and the 9 in that row or column. So in this column here, if that was a 1 and that was a 9, the numbers between the 1 and the 9 would have to add to 24. In this row, the 12, the numbers between, say, that one and that one would have to add to 12. And that's the extent of the rules for this puzzle. So there's a link in the description below if you'd like to try it yourself, and pause the video, and then if you have any problems you can come back and I'll do the solution now. So starting off in this one here, that's got to be a 1, 3, 7 or 5, somewhere around there. Now because that's a bulb on a thermometer, that can't be anything less than a 1, so that one can't be a 1. I'll put in the numbers that can go here. We can't have a 1 because there's a 1 there. We can have a 2, can't have a 3, we can have a 4. We could normally have a 6, but you've got to have a 3, 6 pair with a 1 to 2 ratio, so we can't have a 3 or a 6 there because there's got to be a 3 over here. We can have an 8 as well, can't have a 5, 7 or 9 there. Then that means there has to be a 4 there because it can only be 2, 4 or 4, 8. So one of those is a 4. This here now, we'll go down to the Renban line. So if that was a 1, we would have to have a 2, 3 there. So that can't be a 1 because the 3's got to be up there. Oops, sorry, it cannot be a 1. Oh, I'm clicked on the wrong box. Can't be a 1. If that's a 3, we'd need a 1, 2, which we can't have because of the 1 there. We can't have a 4, 5. There's a 4 there and a 5 there, so that can't be a 3. A 5 would have to be 4, 5, 6 or 5, 6, 7. We can't have that because there's a 7 there. So that only leaves us with a 7. I'll just check that that's possible. We could have 7, 6, 7, 8 is okay, and 7, 8, 9 is okay. So that, yeah, that can be a 7. And then this one has to be a 6, 8 or 9 with a definite 8 in there either way. And then that one's a 6 or a 9. The only thing I can do, I can eliminate that 5 there now because you can't have a 5 before one of those. And I think that's all that can be. Oh no, I could eliminate the 8 there because I know there's an 8 definitely in that box there now. So that don't need those little 4s there now. We know that's a 2, 4 definite. Now I'll have to go up to this one. So this here could be 1, 2, no, not 1, 2, sorry, we're doing a 4 to 1 ratio now, so it can only be a 1, 4 or a 2, 8 pair. Okay, that obviously can't be an 8 because you couldn't have 9, 10 going up there on the thermometer, so that can't be 8, 2. You can't have a 1 there because you'd have to have a number smaller than it on the thermometer, so that can't be a 1, 4. And what other one can I eliminate? That 1, if that was a 1, we'd have to have a 2, 3 there. And this one here has to be a 1, 2, 3. I'll just put them in to show you. If that was a 1, we can't have, yeah, okay, and that's a 4. This would have to be either a 1, 2, 3 here, and then we've got to put in a 1, 2, 3 there. So that's not possible, is it, either? Because we've got 5 boxes there and only 4 numbers. So that means that can't be a 1, that has to be an 8. Is the only other solution there. So that's a 2, and then that has to be less than a 2, so it has to be a 1. And now that one has to be, can be 6, 7, 8 or 7, 8, 9. And that means there is a definite 7 in there. Can't tell, they could be anything at this point. That one could be anything at this point. But we have a new dot here, we'll go on this. So that can't be a 1, that can be a 2, can be a 3, a 4. It can be a 4, but it can't be a 4, 2. I'll do that in a minute because of that 2, 4 there. It can be a 6 and it can be an 8. Oh, not an 8, sorry, there's an 8 there. So we can't have anything else there. Can be 2. So there's only ever 2, 3, 4, 6, 8 or 1 because you can't have 5, 7, 9 as a 2 to 1 ratio. Alright, so what can go here with these? A 2 can have a 1 with it. It could normally have a 4, but because of this 2, 4 here, we can't have a 2, 4 pair here. The 3 could have a 6. A 4 could normally have a 2, but it can't now because of that again. It could have an 8 with the 4 or a 3 with the 6. So that's all we can have there. And I've come to a bit of a halt there. I don't know how long that cage is going to be, so I can't do anything with that just yet. This sandwich sum here now will be the next thing to look at. A 1 and a 9 can't go there with an 8 in the middle. We've got to have 24 between them. So that can't be 9. Now, I made a wrong assumption in my first video I did. I assumed the 1s had to go down here, but they actually don't, because you could have a 9 down here and a 1 up here at this point. I can disprove that later, but I assumed that a bit too early. So thank you for the person that pointed that out, and I have redone the video to do it the right way around. So using this 24 here, we can tell, however, that there has to be a 9 up here somewhere, because you can't have a 24, you'd need at least 3 spots between the 1 and the 9. So it's going to be 3 or 4 spots. And if you look there, if you try to put the 9 there, you've got 9 or 10 left that you have to, because that's 15 or 14, which leaves 9 or 10. And you would need 2 spots for a 9 or 10, because you can't put 9, 9. So that means you need 2 spots, so the 9 there has to go there. And that didn't give us anything. And now with this 21, yeah, so the 1s could go down here, but you could at this point, you can't have a 9 here actually because of that row, but you could have a 9 there and a 1 up there with all these ones adding to 21. So we'll have to firstly, before I assume that it goes that way, we have to prove that there's not a 1 or down in this spot down here somewhere, or a 9, sorry, rather. So we'll have to do this row here first, I think, which is the 12. So where can we have a 1, 9 along here? Now, if that's a 1, then that can't be a 9 there. Let's just see if this 1 here works first. If that's a 1, we can't have a 9 there because that doesn't add up to 12 enough. It would have to go there for those 3. It can't go there because, well, it certainly can't go over here. You can't get 4 numbers to add up to 12. Once you take the 1 away, the smallest you can get for 4 numbers is 5, 4, 3, 2, which is 14, isn't it? 9, 10, 11, 12, 13, 14, yes. So that means if the 1's there, the 9 has to go there. So I'll see if that works with the 3, 5, 4. What could we have in here with the 5? So if it's 5 and 4 is 9, you'd have to have a 3. I'll put the options in. 5, 4 makes 9. You'd have to have a 3 in there, wouldn't you? And then the problem is over here, if that's a 1, that can't be a 1, 2. It can't be a 4, 8, and it can't be a 3, 6. So we've got no options to put in there with these numbers here. So those 3 don't work. So what about 5, 2? That's 7. And then you need a 5 in there to make 12. So you can't have 2 5s, so that won't work. The 3, 4 is 7, and then the 5. And then we've got the same problem over here again. You can't have a 3, 6. You can't have a 4, 8. And you can't have the 2, 1 because of the 1, so that doesn't work. Which one did I just do then? 3, 5. Sorry, 3, 4, so I'm going to do 3, 2. 3, 2 is 5 and 7. And to make 12 there. And then we can't have the 2, 1. We can't have the 3, 6. We could have the 4, 8 though. This looks like it might work. Maybe 4, 8. But then with this cage here, it's got to, the cage, you can see it continues. It's got to at least go to there, and then we'd have 8 and 9 in the cage, which would be 17. So that one doesn't work either. So none of those possibilities work, which means the 9 and the can't go there. And because that's the only spot the 9 can go with the 1, that means there's not a 1 in there. Now that's good because that gives us a 1 here, and it gives us a 3, 5 pair here, which eliminates the possibility of a 3, 6 there. So now where can the 1, 9 go? If that's a 1, the only spot for a 9 is there, isn't it? Now, is that possible? 9 and 1's 10. We'd have that would the cage. Does the cage have to go to there? Though it doesn't. It could go there or around the corner, couldn't it? Think about that for a second. Oh, actually, can a 1 not go there anyway? Because if you look at the sandwich sum here, where could the 9 go? Can't go there. Can't go there. The 9. You can't get 2 numbers that add to 21. The 9 would have to go up into this thing, and it can't. To get 3 numbers, so it actually can't be a 1 there. Don't even need to check that. That actually has to be a 4, 8 pair in that case. Oops, that's not a 4. 4, and that has to be an 8. There's a 2 and a 4. And now what do we do now? There's so many different options. I'll just check because on this roll with the 1, 9, where can the 1, 9 go? So it can't go there and there. So one of them's got to go there. And then obviously the next one has to go there, because if it goes there, it's more than 12. So there's the other 1, 9. And that leaves us with a 6, 7 in here. And now that that bit of fog's been cleared, we can see that this grey line joins up through there. So that means this has to be a palindrome line all the way along, which means the ends have to be the same. So it's got to be a 4. And now in this cage here, we can have a, can't have a, they've got to add to 10 to get 14. So we can't have a 1, so it can't be 1, 9. We can't have an 8 there. We could have an 8 there, but we can't have a 2 there, so it can't be an 8, 2. Can't be another 4, so it can't be 6, 4. So 3, 7's the only option there, and the 3 has to go there because there's a 7 up there. So that gives us that one's a 7, that one's a 6. And now this cage here, 6 and 8 is 14, that's a 1, and that there is a 9. And now we might be able to get the sandwich sum here. Now, we still can't assume the 9 goes there. It's still, oh, yes, we can, because it can't go down here now, and it can't go up there. So there's got to be a 9. In fact, there has to be a 9 right there, the only spot for it. So now the 1 has to go down here, doesn't it? 3, 7, 15, yes, and that has to be a 6. So we've got 6 and 1. And then we might be able to do this. What can go in here? Oh, that had to be a 7, didn't it? With an 8 and a 9. That leaves a 5, 6 pair there. So that can be 5, 6. That one can't be 7, 8 or 9. So it will have to be a 6 after the 5. And that one can't be an 8 or 9, has to be a 7. So that has to be the 5, and that is the 6. Where to now? This one here will do. That's after a 7 on the German whisper line. That can only be a 1 or a 2. So it's got to be a 1 to be 5 away from the 7. That one has to be now a 6 or a 9 because we've got a 7, 8 there. Then that one has to be a 1 or a 3. And that's all I think I can see up there. The 4, 3 could be either in any of those spots at the moment. I'll go down to this circle here. What can we put in this circle? 1, 2, can't have a 3 because it's obviously got to be 3 things that add up to that. Can't be a 4, can only be a 5, can't be a 6, can't be a 7, an 8 or a 9. Okay, so can it actually be a 5? We've already got a 1 used up, so there's not 3 things that add to a 5, so it can't be a 5. Can it be an 8? Actually, the smallest 3 numbers without a 1 add up to 9, don't they? 4, 5, 6, 7, 8, 9. So that has to be a 9. And they have to be the 3 numbers, which is a 2, 3, 4. It's the only options in there. And now the 8 can't go there, so it has to go there. And there's a 5 left over, which has to go there. And I'll put the options in here. We've got a 2, 3, 1, 2, 3, 4, 5. So that's a 2, 3, 5 in there, which gives us that one. And that gives that one, and gives that one. And that's not a 2. And then we've got a 2, 3, 4, 5, 6, 2, 7 left there. The 2 has to go there. And the 7 goes there. And now it's a bit of a, we look a bit stuck. I'll have to work on this one here, but there's a number there I can get. That's a 3 now, isn't it? I think there's a 3 missing in that column. And also that sandwich sum would now add up to 24 with 3. Yep, so that works. So now we have to do this. Now there's a little tiny blue line in that corner there which goes up to there at least. So what can we have here? Can't have 4, we could have 5, can't have 6, can't have 7, we could have 8 or 9, but obviously it's got to, actually we can't even have 8 because it would have to go 9, 10 then. So that's got to be a 5. Oops, wrong one. Twit. That box there has to be a 5. That's a 3. That's a 5. Now this has to be 6, 7, 8, 9. 8, 9, because we've already got the 6, 7 there. That gives that one's a 6, and that one is now a 1. I'll just get rid of these ones down here. And that's not a 9. Does that give us a, yeah, that gives us a 6, 9 pair, so that one's got to be the 8. Now we've got a new little piece of information up here. Now the 9 can't go there, and a 9 can't, because that's an arrow, you couldn't have a 9 on the line of the arrow, could you? Because it's got to add up to the circle at the end. So that can't be a 9 either. So that one there has to be a 9. And now we can get the 1, can't go there, that has to be a 1. And ooh, how far that goes we don't know. Could go up there, could go up there, could go down, whoops, down there, or it might stop there. A few too many options there. I'll put some other numbers in here and see what we can get first, I think. So what have we got left to go in here? We've got a 2. Each can't go there or there. The 2 has to go there. 1, 2, a 3, and a 9. The 9 can't go in that box. It has to go there. And the 3 has to go there. What's in the next row? 1, 2, 3. We need a 4. Can I tell where that goes? It's there or there. 4 is there or there. 5 is there or there. Isn't? Oh, why can't I have a 5? Oh, there's a 5 in there, that box there. Ah, well, that is cool. That means the 5 can't go there or there. That means that one has to be a 5, and that gives us the 4. And then 1, 2, 3, 4, 5, 6, 7 goes there. And now in this one we have a 2, 6 pair. I can't tell where they go, I don't think. And in here we've got to have a 4, 3 pair there. Can't tell which way around they go. And that leaves 1, 2, 3, 4, 5, 6, and 8 for there. I'm trying to be a bit more careful with my checking it. I keep not looking carefully enough and missing things. Now what? I'm going to just have to put some numbers in and hope that we get something, I think. So 1, 2, that's got to be a 3, 4 something. 3, 4, 8 is missing there. That's not a 3, and that didn't resolve anything. I'll see what we can get on this line here. 1, 2, 6. What's the other number missing there? 1, 2, 3, 4. Looks like there's no 4 there. 1, 2, 6, 4. That's not a 1 or a 6. That didn't particularly help. We'll try this one. 1, 2, 3, 4. That's got to be a 5, a 6, and 8, and a 9. That's not a 9. That's not a 6 or a 9. So that one has helped because it can't be an 8 there, because you'd have to have a 1 and another 0 to add up to 9. So that has to be a 5. Get rid of that 5. And now going along that line, that can't be a 4, can't be a 6. What do we need? We need 3 there, so we've got to have a 2, 1. The 1 can't go there, that's got to be a 1. And that's got to be a 2. That's a 4. That's a 6. And that's a 6. 6, 2 now. Now what? That one up here. Oh, I've got a 9 down here. And a 6. And that is now an 8 and a 9. Not an 8. What's left up here? 1, 2, 3, 7. Can we tell where they go? We can. The 7 has to go there. The 3 has to go there. That's now the 4 and the 8. Should be just hopefully a matter of doing normal old Sudoku from here on in. These two have to be 1, 2, 3, 4, 5, 5, 7, I think. That's a 5. That's a 7. That's across here. 1, 2, 3 has to go there. 4, 5, 6, and 8 has to go there. In here we've got 2 and can't tell where that goes. No, 1, 2, 3, 4, 5, and a 6. And so the 6 has to go there. 2 there. This box needs a 1, which can't go there or there. It's got to go there. 1 and 2, which has to go there. 3, a 4 has to go there. And a 5 has to go there. There we go. Congrats to us. Solved the puzzle. Solution is correct. So there you go. I hope you enjoyed that one. And thanks very much to that person who pointed out that I made an assumption in here earlier that I shouldn't have. I should have done this whole row first, and that showed that there was a 9 here. So I just sort of did it the other way around. It's a bit hard when you know the answer it's hard sometimes not to assume things and to make sure that you actually prove all the answers before you put them in. So I'll have to be much more careful doing that in the future. So thank you very much for pointing that out for me, and I hope you enjoyed that one, and I'll see you next time.